Hey everybody, this is Archibald Bunker, and this is a review for your test on Chapter 2. Let's begin. Okay, let's do board problem 11 here. Okay, and go ahead and pause it right here. I'm not going to go through these with you guys because you've done them before. Okay, so pause it and work them out, and you should get those as your answers right there. This one I did on board problem 10B, so go back to section 2.6 and you'll see that one right there. Okay, the work on that one. Alright, so here we go. Solve each system of equations. Again, pause these and work these out yourself, you guys. I know some of you guys aren't going to pause, and that's cool. But you should get 6, -4. Okay, here's another one. These are Algebra 1 skills, you guys, so hopefully you get those okay. You get 2, -4. Here's another system of equations from your Algebra 1 class, but I did teach this in Chapter 1 of this class also. Okay, you should get 1, 2. Okay, I'm still not going to go over this one. This is a system of 3 variables here. So you can check out the videos on how to do that. I would probably get rid of x first, multiply this equation times 3, and then add it to this one. And then same with this one, multiply it times 3 and add it to this one. And then you're going to solve that, and you should get that as your solution. Okay, on this one, I would probably choose. Well, actually, the z's are ready to go. Add these together and they cancel out, and then add these together and they cancel out, and then you should be able to solve that. And if you don't know what I'm talking about, please go see. I think it's section 2.4, 2.5, something like that, when you're solving systems of 3 variables. All right, say in this one also, another easy one. Here I'm just going to let this equal this and let this equal this, and solve for x and y. You get another system of equations. You get 1, 2. Same on this one. You get a system of equations. You get 4, -5. Okay. All right. Now these parts I broke down a little bit because this was the new stuff basically. So a trapezoid has vertices L, M, N, and P. And find the coordinates of the dilated trapezoid with a scale factor of 0.5, and then graph. Okay, there's L, M, N, P as a matrix, you guys. Okay, can you see this is my x, y, x, y, x, y, x, y. So now I'm going to multiply all those numbers by 0.5. Okay, and it gets me this right here. Okay, so there's my vertices of my new matrix. Okay, L prime, M prime, N prime, and P prime from this right here, x, y, x, y, x, y, x, y. Okay, and then there's the graph of LMNP, and then the dilated one, the scale factor of a half right there inside. Okay, all right, so given triangle JKL with vertices JK and L, -6, 4, -3, 2, -1, -2, find the transformation of each and then graph. Okay, so here I want you to rotate the followed by a translation 2 units left and 5 units up. Okay, let's do the rotating by 180 degrees. Okay, remember the rule when you do that is you multiply it by -1, 0, 0, -1. Okay, then you get this guy right here. Okay, so then it gives me my triangle then becomes 6, -4, 3, -2, 1, 2. Okay, and that's J prime, K prime, and L prime. All right, now I'm going to translate the units 2 units to the left, which just means subtract 2 from all the x's. 6 minus 2 is 4. 3 minus 2 is 1. 1 minus 2 is -1. And then 5 units up means add 5 to all the y's. Okay, so add 5 to all the y's. All right, now we graph all those. Okay, there it is right there. Okay, and they're all congruent to each other. They're just moved over and rotated 180 degrees. Okay. All right, so given this is number 2, you guys. Same problem, but number 2. We're going to rotate it. Now you remember f of x of y? Or say we did f of g of x. I'm sorry, f of g of x. Remember that? You plugged in g into x from Algebra 2. Well, here we do this rotating about the x-axis first, and then we'll rotate that answer about the y-axis. Okay, when it rotates about the x-axis, you just change all the y values, okay? Change the sign. So this -4 becomes, I'm sorry, this +4 becomes negative. This +2 becomes -2, and this -2 becomes +2. The x's stay the same. Okay, so there it is, rotated about the x-axis. Now I'm going to rotate it about the y-axis. That means change all the x's. Okay, so here's J prime and here's J double prime, okay? All right, and then so we did that. Now we're going to graph those guys, and there it is right there. Alrighty, let's see. Now we have some determinants. Find the value of each determinant. Okay, Hopefully you're pausing this and so you have time to write this down. My students do. I try to make these videos short so you can pause them at your will. Okay, this 2 by 2 we do 12 times 32 minus negative 15 times negative 26. Remember that? Nice and easy. You get negative 6. Okay, number 2, got to add those first 2 columns, and then we go diagonal. Okay, so I'm going to go the blue guys first and then minus the purple guys. All right, and then that comes out to negative 413 when you do all of that. All right, what else do I have? Okay, and then find the max and min of the function f of xy equals 5x minus 3y for the polygon that's bounded by these guys. Okay, so when you graph those guys, you get that graph right there, and then we're interested in all the vertices where the graph intersects, and then we plug all these vertices into f of xy equals 5x minus 3y, and we want to see which one calculates the max or the min. So I put in all of these points right here, these 5 different points, 2, 4, 5, 1, 5, 0, 0, 0, 0, 2, plug them in to 5x minus 3y, and the max is at 25 at 5, 0, and the min is, looks like negative 6 at 0, 2, okay? All right, and then if you're in my pre-calculus class, that would be your homework.